Okay, I'm going to reveal the answers for Chapter 6, Part 2. This is in the test review. The first part is all about composite functions. And just remember that when it says f composed of g, we're plugging g in to f. So you're plugging g into f and going from there. Sorry, I got the right marker. So this one is saying plug f into g. And when you're doing that, I did this on a lot of people's papers today. You are going to replace that x. You're going to replace that x with x minus 2. So it's going to look like that. You expand it out by squaring this. You get a square before you multiply by 3, and you get that as a final answer. And then this is saying evaluate the first one, 3x squared minus 2. Evaluate it at -3. So plug in -3 for x and evaluate it. So that's 9. -3 squared is 9 times 3 is 27, minus 2 is the 25. And this one is saying I can use the original if I want. It's actually a little bit easier. If I plug in -3 minus 2, then square it. That is 3. That's -5 inside there squared. So that's -5 squared is 25 times 3 is the 75. Okay, and so forth. So the second one, I'll just show the answers. So that's f composed of g, and this is g composed of f. And all I did is plug in -3. So 6 plus 12 gives you the 18. And then g composed of f was just -2x because these two canceled out. So -2 times -3 is obviously 6. And then the last one, g composed of g, you have to plug g into itself, basically. So it looks like that. It reduces all the way down to 4x minus 8. And it's saying plug in 2. So I plugged in 2 for x, and I got 0. Okay, down here, this is telling you to add the two functions. This one's telling you to subtract, and this one's telling you to multiply. So that's exactly what I did. I added like terms. These two cross out because they're opposites. And then I have 6x, and I have a -1 and a -9 to make the -10. This, you have to be careful when you subtract. You're subtracting the entire quantity, not just the -2. So we've done this several times this year where you have to distribute a -1 to all those things. It's really just a sign changer. So this turns positive, negative, positive. It's kind of small right there. Hopefully you can see it. And you collect like terms. That's 4x squared. It looks like you have a -6x that's by itself. And then -1 and 9 make 8. And then we called this a superfoil, or really just distributing twice, and you have some like terms to collect and go from there. So your final answer is this down here. Okay, flip it over, doing more of the same. So you're going to add, subtract, multiply, then there's actually division at the end. And dividing isn't too hard because you're just going to factor the top if you can, and it does factor to, hopefully you can see that, x plus 6 and x plus 2, so that factors. You have an x plus 6 on the bottom, so those end up canceling out, and you're left with just the x plus 2. Going up, since I'm working backwards, again, this is just a superfoil. This is subtract, so we are subtracting x and the 6. So x squared is by itself. 8x minus 1x is 7x, and 12 minus 6 is the 6. Up here you're just adding, they're all positive. That should be the easiest problem on the whole test. Okay, finding the inverse of a function. So this is the original graph, and there's the original equation. The steps are switch x and y. So switch x and y, then solve for y. So right now, once I switched them, I have x equals, I have to do a couple steps here. So I added 4 to both sides, and then to show my work here, I can put the y with the 2, and really in 2 steps I could get this done. I can multiply by 3, both sides by 3, and that's going to cancel that out. And then I have 3x plus 12 equals 2y. Then I'm going to divide everything by 2, and that's going to be 3 halves x. 12 divided by 2 is the 6. That's going to cancel out. So that's one way you could do it, or you could multiply both sides by 3 halves. That's the more advanced way to do it. Either way, that is your inverse. So I go ahead and graph this. Thing crosses at 6. It goes up 3 and over 2, the slope, and you graph it. Remember, a check you can always do. It should be symmetrical along the line y equals x, which is just this perfect diagonal right here. And if you look at my 2 lines, if you fold them along the dotted line, they would be symmetrical. Okay, at the bottom of the page here, 1 second. Ugh. So, the original is y equals, in case you can't see it, y equals x cubed plus 3. I switched the x and the y, solved for y. I have to graph both equations. You notice that I used an xy chart. You guys are allowed to use your graphing calculator. But I know 9 minus 1 makes 8, and the cube root of 8 is 2. So, you know, very quickly I got a few points, 9, 2. You know, I got these 5 points fairly quickly and was able to graph my inverse. So this is the graph of the inverse. And we do expect that. You know, cube roots are on their sides, and then this is y equals x cubed plus 1. Those go up and down. So just take a look at that. Again, this is still symmetrical along that line. Alright, exponents. A lot of you guys need to go back to the very basics today. That b to the xy equals just like that. So if you can memorize that, that's going to help you a whole lot, because the root of this is 2. We don't really write it, but we know it's all to the first power. So square roots are to the 1/2, and cube roots are to the 1/3. So hopefully you can see that is a little bit smaller than usual. There you go. Alright, so the directions for this is write in radical form and simplify. Okay, so not only do you have to go back to radical form, but you have to simplify it also. Now the square root of 3 is just 3, so that's a final answer. same thing with this. You can't simplify the square root of x, y. You can't simplify that. That's perfect. But then this answer, 45x squared, y to the 7th, the square root of that can definitely be reduced. And we did this before. That's 9 times 5. I split it into 9 times 5 because 9 is a perfect square. X squared is already a perfect square. And then I split this 7 into 6 times 1 because that is now a perfect square. So I have these 3 perfect squares that are going to come out front. The 9 becomes a 3, the x squared. Square root of x squared is x. The square root of x, or y to the 6th, is y to the 3rd. And what's left? A 5 and a y. So that's your final answer. Simplified. Okay, so you'd get a point for this, writing it in radical form, and you'd also get a point for simplifying it. Okay, this one is a cube root of 125 x to the 3rd y to the 6th. All right, so now we got to think about our perfect cubes. 5 cubed is 125. So that's a perfect cube. The cube root of x cubed is x. And the cube root of y to the 6th is y squared. So all 3 of these are perfect cubes. You have 5x y squared. And another way you can check your answer on this is if you cube this, you should get, if you cube your answer, you should get what's underneath the radical. So 5 cubed is 125, x to the 3rd power is x cubed, and y to the 2nd to the 3rd power is y to the 6th. So that's another way, oops, I was off. That's another way you can check that. All I did was I took my answer, I cubed it, and I should get back to the original. All right, so number 16. Can't read that. That's 49x to the 8th. Well, both of these are perfect squares. Square root of 49 is 7. Square root of x to the 8th is x to the 4th. So that's number 16. Number 17, perfect cube. Perfect cube, that one is not, so that's going to stay underneath. So the cube root of 27 is 3. Cube root of y to the 9th is y to the 3rd. And then there's an x left underneath. So that's number 17. And then these, you're really just going to use your calculator. But if you know that that's square root, that's pretty easy. Square root of 81 is 9. Cube root of 216 is 6. Now, this, if you rewrite it, it's a square root of 36 to the 5th power. You could also just type in your calculator with the caret button, and 36 to the 5 halves should spit out 7,776. Okay, and so forth. So look at those answers. Okay, very last thing. Now, I know the directions said put it in radical form, but cross that out. All I want you to do is simplify this. So when you're multiplying exponents, you add them. So you do 3/4 plus 1/8 to get the 7/8. Okay, very easy. You can put it in your calculator, or make this 6/8 plus 1/8 makes the 7/8. You have to have a common denominator to add fractions. Okay, so that becomes x to the 7/8. This one, when you do a power to a power, the rule is you take 2/4 and you multiply it by 7/3. You do not need a common denominator when multiplying. So that reduces, you multiply straight across. It's 14 divided by 12, that's 7/6. So this becomes x to the 7/6. When you divide, you subtract. You do need a common denominator when you subtract. So I'm going to take the two exponents and I'm going to subtract them. make this 12ths, make them both 12ths. Multiply that by 4, you get 16. Multiply that by 3, you get 9. You reduce it, you get 7/12. Now, since it's a positive 7/12, it is what it is. So you get x to the 7/12. And then 27 is exactly like 24.